So we're on to question 3. Question 3 is probably a popular question among students. It starts off with a visual that they'll certainly recognize. It says diagram 1 shows the sketch of y equals x squared. So our quadratic graph. Diagram 2, 3, and 4 show the sketch of the graph y equals x squared after it's been moved parallel to the x-axis, parallel to the y-axis, or parallel to both. So here's diagram 2. In diagram 2, we can see that there's been a transformation upwards by 3 units, and you're asked to write down the equation of the graph, in this case shown in diagram 2, and in this case it's simply y is equal to x squared plus 3 because it's just an upward translation of 3 units, and that's worth 5 marks. So we'd be hoping that students would have gotten that 5 marks. And then as we move on to the A part 2, you're asked for the equation when the diagram and the graph shifts 2 units to the right-hand side. Now, oftentimes students will make a little mistake in this because the answer is actually y equals x minus 2 to be squared. And you could understand why students might have a plus instead of the minus. But in this case, how I always explain it to students why it's the minus 2, if you put in 2 here for x, of course you'll get 2 minus 2, which is 0, and 0 squared is 0. So when x is 2, y is 0, the lowest point in the curve where it's a tangent to the x-axis. However, if it was x plus 2, of course, that wouldn't work. So the answer is x minus 2 to be squared, and that was 5 marks. Our third part here is diagram 4, and we're asked to get the equation when it moves 3 units upwards and then 2 units to the right is the combination of the first 2. So it's the x minus 2 to be squared, so the minus 2 within the bracket, and the plus 3 outside of the bracket. So x minus 2 to be squared plus 3. And again, your lowest point in this case would be the point 2, 3. Okay, so that was another 5 marks. So we move on to part B. It says sketch the graph with the equation y equals the modulus of 4x minus 3, stating the coordinates of any point where the graph cuts or meets the axis. Okay, so as I always say, if you don't know what to do what you know. So students might have to think about a little bit how to do this question, how to start off. But when you look at it, y equals the modulus of 4x minus 3. In the simplest case, you could just put in a number of values in for x, get out different values for y and plot that. And on the Casio or the new Sharp, you could use the table function. Or you might even just recognize how to go about it. But let's take just a couple of values. We put in when x equals 0, we're going to get y equals the modulus of 4 times 0 minus 3. That's the modulus of minus 3. And of course, the modulus of minus 3 is 3. So that's our point 0, 3. When y equals 0, so that's when x equals 0. So we have 0.03 when y is equal to 0. Well, in this case, we'll have 0 is equal to the modulus of 4x minus 3. So in that case, well, there's a number of things you could do. You could take what the simplest way is to think about it and take in terms of taking the plus or minus case. So the modulus of 4x minus 3 is equal to 0. So you can say 4x minus 3 is equal to plus or minus 0. But of course, plus 0 and minus 0 are the same. So they will just be 0. So you get this line, 4x is equal to 3, x is equal to 0.75. So when x is equal to 0.75, y will be equal to 0. So now we have 2 crucial points here that will help us to plot the function. But as I said, if you're unsure, sometimes students wouldn't be certain that this would be the lowest point, 0.750. But if you're unsure, of course, you can put in more values for x just to get yourself a bit more confidence in terms of what exactly the shape of the graph is going to look like. So that was 5 marks. And then our final part was to complete and find the complete set of values for which of x for which the modulus of 4x minus 3 is greater than 2x, than 2 minus 2x. So this is a line, of course. So if I plot the line y is equal to 2 minus 2x, it'll look like that. Y is equal to 2 minus 2x. And I'm saying, well, okay, where is the modulus of 4x minus 3 greater than that? So of course we can see there's 2 points of contact here, you know, points of intersection of the curves. So I can say, well, to the left of this point here, we can see the red line is above the blue. So the 4x minus 3, the modulus of 4x minus 3 is greater than the 2 minus 2x. And similar to the right of this point, I can say the modulus of 4x minus 3, the V-shaped red curve, is greater than the 2x minus 2. Now, how am I going to go about finding those points? Well, there's a couple of ways. What a lot of people will do, so you can think about it as an equation to find the values of where they're equal to each other. So the most common way to approach it would be to square both sides. That will get rid of the modulus. So you can do, let me just do that a little bit further down actually. So you could do the following. You can say, well, the modulus of 4x minus 3 to be squared is going to be equal to 2 minus 2x to be squared. So what's going to happen? As we know here, to square any binomial, we can square the first part. So I'm going to get 16x squared. One little point actually to note is I've seen that this happened to students before. Sometimes students, when they look at what I've just highlighted there, they'll see a 14x. And they'll make a little mistake then when they're squaring it out. But of course, you got to be careful that it is the modulus of 4x. So you square the first part to get 16x squared. You square the last part, which is the negative 3. That will give you a plus 9 because anything squared is positive. And then you multiply the first term by the last term. 4x times minus 3 is minus 12x. Double that to get minus 24x. We're going to go through a similar process on the right. We square the first term to get 4. We square the last term to get 4x squared. And then we multiply the first term by the last term. That will give you minus 4x. Double that and get minus 8x. So we look here, of course, now we have 2 quadratics. So what I'm going to do is I'm going to subtract. Let me change here to a pen. I'm going to subtract from the right-hand side. I'm going to subtract 4. I'm going to add 4x. I'm going to subtract 4x squared. I'm going to be doing the same thing, of course, to the left-hand side. So I'm going to be adding 8x. I'm going to be subtracting 4. And what is going to happen next? I'm going to get 12x squared plus 16x minus 5 equals 0. A lot of people will go for the minus b formula at that point, but it does factorize. It does factorize through, you could use your guide number process. As I said, you could use the minus b formula, but I think you can say there are going to be factors. You could do different ways. Of course, people might use the big X or trial and error. In this case, if I open up the brackets, I know one possibility would be 2x times 6x would give you 12x squared. I think I made a little typo here that this should be a plus 5. And in fact, actually, let me try this one more time because this should be a negative 16x, shouldn't it? It should be a negative 16x. So 12x squared minus 16x plus 5 equals 0. So what do we do? Okay, I'm looking for 2 numbers which they're going to multiply together to give me this plus 5. So I have various possibilities, but as I look at it here, I can see that I'm going to have a negative 5 here and a negative 1 here. And let me just double check my workings. I know, of course, if I multiply by 2x by my 6x, I get my 12x squared. If I multiply by minus 1 times my minus 5, we will get my plus 5. And then, of course, if I multiply my 2x times -5, that'll give me -10x. If I multiply -1 times 6x, I will get -6x. And if I put that together, I will get my -16x in the middle. So I'm on track. So I can say that's all equal to 0. So I can say I have two brackets multiplied together equals 0. Either the first is 0 or the second is 0. So then I will get solutions. X equals 1/2 or x equals 5/6. So those are going to be my two solutions. So my points here will be x equals 1/2 and x equals 5/6. And of course, from what I described earlier, because I'm looking for the place where the red is above the blue, I'm going to be going to the left of 1/2 and to the right of 5/6. To the left of x equals 1/2 and to the right of x equals 5/6. So my final answer then will become x is less than or equal, less than, I'm just looking back up on my signs from earlier, x is less than 1/2 or x is greater than 5/6. And that will be my answer. Some people will do it a different way. It's basically using the same idea as earlier with what I mentioned, the modules. You can use kind of the plus or minus case. So if I look at this part, that'd be 4x minus 3 is greater than the plus version, 2x minus 2 minus 2x. I just have to be careful here. 4x minus 3 will be less than minus 2 minus 2x. So less than the minus case. And in both of these, when I solve these, when I work these out, I'm going to get x is less than 1/2. And I'm going to end up with x is greater than 5/6. So the same two answers. And that last part was worth 10 marks. So as I said, overall, we would expect that to have been a popular question among students. And we would say hopefully students scored quite well in it. The final part, students might have found a little bit difficult.